In the depths of the blockchain, Pocahontas lurks in the shadows, waiting for anyone who dares to venture into the first 300,000 blocks of the Kusama network. Hi everyone, welcome to Edison Bob. Today I want to share with you the solution to the 1337 riddle of Kusama network. We solved it, and this was one of the most curious things I've ever seen on chain. It started out with a tiny hint of something really curious. Then we went on to an adventure of solving the riddle, first confirming it is an actual riddle, then solving it. And at the end of the video, you can see a complete solution of that. So it basically was a collaborative game, but I'm getting ahead of myself. So in this video, I'm going to show you how did we discover the riddle, how did we solve it, and how does it actually look like. So this was solved together with Gabe from InfArch Network. This was really fun. And, you know, I love a good riddle. When I see something curious on chain, it captures my attention. Right at the moment, I'm building Polkalytics. It's a Google scale analytics service for Polkadot. And it just means that I look at a lot of data. I look at a lot of data. I look at a lot of different blocks to see what is happening on chain, to get a better understanding. And so I was looking around at the very early blocks of the Kusama network. I don't know what I was looking for. But, you know, I was looking at this block and I see, okay, there is a lot of remarks. And remarks are basically just messages that are posted on chain. And so the messages here start with 1337. 1337. And you can find quite a lot of them. So, okay. And you usually don't see such random messages pop up. Usually they have more context or meaning to them. But this almost looks like a code. And it doesn't only happen on a single block. It happens over multiple blocks. And it's always 1337 and then a few numbers and characters, right? So looking at this over several blocks, it caught my attention. You know, okay, so first clue here, 1337, what does it mean? Many of you might know it. 1337 is a code basically from the early internet, from the Counter-Strike and gaming and shooter scene. And it basically just meant cool. But it is a code word for our own subculture. So everyone who knows this, everyone who uses this, knows that it is a code for the early internet scene, I would say. Yeah, so this is basically just a clue that this is not random. This is sort of intentional. At least for me, it's a clue. And so I was wondering, is it a riddle? Was it part of a program? Is it a message? What is it? I was really curious. I was putting it to Twitter here. And I just said I found a riddle. I found an on-chain riddle on Kusama. Posted a screenshot. And was just thinking maybe I can get an answer from someone. Maybe someone has a clue to what this actually means. And a few days later, there was a response from Sean Tabrizi. So Sean Tabrizi is one of the, or maybe the lead developer of Polkadot within the Parity team. Lead developer of Polkadot, right? So, and he said, should I reveal the secrets or can you find the answers on your own? And, you know, this grabs my attention and I don't want to be spoiled. If it's a good secret, I'm willing to go on a treasure hunt and uncover the secret on my own. So yeah, I wanted to solve it, but I wasn't sure how easy or hard it is to solve. So the first thing I did is I created a video. I put a call out for people to join us. If you want to be part of more of these interesting adventures, you can feel free to subscribe. I'm almost at 800 now. But I put out the video and I said, join me on this treasure hunt. Maybe we can find something interesting. And I created a Notion page so that that I can gather all the information that is available and let other people join in this treasure hunt. So I created this page, and now there are a few different ways how you can approach such a riddle, because you get random pieces of information, but they're not random, they have a certain structure to it. So you can start at the micro level and look at the specific extrinsics, at the specific remarks and messages, and maybe try to make sense out of them. Or you can start at the macro level and sort of look at what is the overall shape of the thing, what is the structure, what am I looking at. So the way I started out was that I wanted to look at the macro shape of the thing. So I'm creating this statistic of how many remarks in a certain block range are happening. And you can see it happened in the very first blocks. This is within the first, I think, 3 weeks of Kusama. All of this happened within the first 3 weeks or so, if I'm not mistaken. Maybe it's a longer time span. But you can see here, there is something happening here, tiny bursts, and then there's more happening and more happening, and then there is a cluster of activity here, and a cluster of activity here, and a cluster of activity here. But so it's not regular, it's sort of irregular, but there are bursts of this activity. Okay. So this gives us some clues on what to look at, but we don't have the full structure. So at this point in time, I was happy to see that Gabe from InfArch was joining me. So I was posting this on the KSDAO Discord, and Gabe was there. He had time, and so we went about this together. And so I created a list of all the extrinsics, extracted them from the chain, and it is basically 72,000 extrinsics in this point in time. And most of them, if you look here at this column here, most of them conform to our pattern of 0x1337. Most, you see. There are a few exceptions in the middle, at the end, and then, so we basically captured the data that we want to look at, and now it's time to look at it and try to make sense of it. And this is where the on-chain forensic now come in. Okay, the interesting thing here is it starts very early. So there was only one extrinsic that ever happened, one remark that ever happened before this thing started. And so this is the very first remark ever on Kusama network, and it says 0x dead beef. So you see that this also might conform to a hexadecimal standard. And the interesting thing here is it is posted by the same account that then started 0x1437. So the same user that posted the first ever remark also started this thing. So let's see, can we find out something about this address? I was looking at Subscan, and what you can see is that the user has identified as Jam. So from what I understand, Jam is one of the early, maybe core contributors to Polkadot substrate. I think Jam is no longer with the team, if I understand it correctly, but has been one of the early contributors to the thing. And okay, so was it maybe the developer of the remark feature? Was it was Jam responsible for integrating it? It sort of fits together with Sean Tabrizi giving us this hint of that there is something to it. So this seems to be something that has been originating by the developers of Polkadot. Okay. Yeah, so this might look like a code. And so Gabe and I started to look at this and trying to find some structure in this. And on the Notion page here, we started to gather some clues. We tried to extract some structure here. And so the first thing that sort of became visible is there is a certain kind of pattern. So I was thinking of maybe there is a hint here on UDC 500, 500, AB, AB, AB. So it seems like there is a structure here and there's a structure here. And now I really have to take care to not nerd too deeply into this, but you see we were sort of taking this apart and finding pieces of structure here and there. And maybe to fast forward here a little bit, we've been looking at a lot of patterns, and then we saw some structure, and maybe there were words. Is it words? Is it maybe different messages? And then we started to discover some similarities when we plotted it in 2 dimensions. Yeah, it's getting nerdy here. But then, fast forward here, Gabe actually got the most important clue, because we were looking at this, and then Gabe said, there's a lot of AXD, XEX. Wait, what? And then and then we got it. These are colors. So how can this be a color? So the last 6 characters here could be read as the RGB colors, how they're usually represented in the web. So for example, if you want to have this light blue here, what you use is A1, D9, E6, right? And so we saw, okay, the last part are colors. So, but when you have colors, what do you get? You get likely a picture. So how is a picture represented? It's represented in 2 dimensions. So next thing we understood is this are likely going to be coordinates. This have to be some form of coordinates. Okay, and now you see that you start to see that there are also 2 segments to this. There is this segment and this segment. Okay, so this was the point when it really clicked for us, and we understood this is X and Y coordinates, and this is the color. So this is basically each of those remarks is 1 pixel each. And we get 70,000 messages on chain, 1 pixel each. And we were mind blown. And one of the early things we did is we were thinking, okay, how much did this have to cost? And if I remember correctly, I ran the math, and I think it would cost you today 22 KSM. So this would be, I think, $900 today or so, that you would have to spend to put all those pixels on chain. Okay, now we know it's pixels getting on chain, but we still don't know what is this? Is it a drawing game? Was it an algorithm that was imprinting an image onto the chain? Or what was happening here? So this is where my coding skills came in. I created an export of all the coordinates, X, Y, and the pixel that is being drawn. I wrote a very short Python script that basically extracted out. So, you know, each of these lines is 1 pixel being drawn after the other. So I could run through all of these pixels and then draw out a picture every time a new pixel is drawn. So, not sure if we got this here. Yeah, so, you know, we got all of those images out, and it started out with image 0, which is basically a black canvas, and then at the center there is a tiny white pixel. And if you start to go forward in time, 180 pixels later, it's likely going to be a very similar situation where you just have a few pixels. Shouldn't have closed this. Nicht jetzt. Okay, and you still only see a few pixels. Okay, now let's go forward much further in time. Let's go 90,000 blocks in. Oh, there are things appearing. Okay, so what I did is I was rendering out all of those pixels, and I was then putting them together into a movie, and this is the movie that you're going to see now. This is the solution of the 1337 riddle of Kusama.